Here we go. Now it's time to revise the chi-squared test for independence. Sometimes they, in the exam, will instead just call it the x-squared test. So remember, chi-squared test for independence is very calculator friendly, so you need to have your calculators ready. So please have it ready, because this is a really popular topic on exams. It's always going to appear on a math study exam. It can either appear on paper 1 or paper 2. It can appear on both. So please make sure you know this. In this little tutorial, pretty much it goes over the basics of it. Well, probably most of what you need to know anyway, to be honest. So please make sure to watch it with the volume up so you hear the little tips. So we've got a question 1, chi-square test. 100 students are asked, let's go question 1, 100 students are asked how many meals on average they have per day. The data collected is organized in the following table. So see what we have here. How many rows and how many columns do we have? We have 2 rows and we have 3 columns. Remember, we don't count the totals. So 2 rows by 3 columns. So it's a 2 by 3. So we've got male and female as our gender. Number of meals per day is 3 or fewer, 4 to 5 or more than 5. When we're talking about what size matrix it is, it's the rows by the columns. Rows by columns. So 2 by 3. Don't include the totals. A chi-square test, see how they don't often write the word chi-square? They might say an x-squared test. It just means a chi-squared test. So a chi-squared test is carried out at a 5% significance level. That's an important thing to note. Write down the null hypothesis, which is also sometimes they don't say the word null hypothesis. Sometimes I find the HO for this test. So remember, the null hypothesis is easy. You just have to write the sentence. Null is German for nothing. So it means that there's no relationship between them. The words you have to use are independent. So what you need to say are what the two things are, and then say at the end, are independent. Remember, the opposite is the alternate hypothesis, which they call H1, and for that you say they are dependent. So what are the 2 variables? We've got gender. So write the 2 variables. The null hypothesis is gender, and what's the other variable? Have a look. It's how many meals on average. And average number of meals. So gender and average number of meals per day. Write what they've called it. And then what you write is are independent. You don't say that one relates to another. Just write the 2 variables, gender and average number of meals per day. And then at the end write are independent. That's the null hypothesis. If they wanted the alternate hypothesis, you just write are dependent at the end instead. And make sure you write the full sentence. This is question A finished, so that's 1 mark. B, write down the number of degrees of freedom for this test. So remember the formula for degrees of freedom. I'll write it out for you. Degrees of freedom equals the number of rows minus 1 multiplied by the number of columns minus 1. So number of rows minus 1 multiplied by the number of columns minus 1. Having a look above, how many rows do we have in our matrix? We have 2 rows, male and female. So we just write 2 minus 1 for the rows. How many columns do we have? We have 3 columns for the number of meals. Remember, we don't include the totals for either of those. 3 minus 1. Pop that in a calculator if you like. If you're not sure how to do it, just pop it in the calculator, as I said. So you could go brackets. Let's see if this would like to work. Oops, just put the pen down, sorry. So brackets. Still doesn't want to work. I'll try it one more time. Brackets 2. It doesn't work. Sorry. Clear. I don't know what's going on with it today. Oh, it's because I've written on it beforehand. Sorry, delete that. Delete. Okay, now it's going to work. So we just go brackets if you want. 2 minus 1, 2 subtract 1. Close brackets. If you're not sure how to do this by hand, this is how you would do it. 3 minus 1. Close brackets. See, we've worked it out. What's the answer? It's 2, which makes sense because 2 minus 1 is 1, 3 minus 1 is 2. So the answer is 2. Done. Degrees of freedom for the test is 2. Next question. C. Show that the expected number, remember to find expected frequency, expected number of females that have more than 5 meals per day is 13, correct to the nearest integer. So integer means whole number. So we've got to just prove that the expected number for female and more than 5 meals per day is 13. So let's see, female. So what you've got to do is you've got to do the row total, just to remind you, by the column total, divide by total. So remember, that's a multiply there. Sometimes people think it's an add. So let's see, for females and 5 meals per day. So let's see, females and 5 meals per day is, females and more than 5 meals per day is here. So it's just a coincidence, it's 13. What's its row total? Its row total is 45. Its column total is 28. And the total is 100. So we've got to do row total by column total, divide by total. So row total was, as you can see, 45, multiplied by column total, 28, divide by total. And they've told us that should equal 13. If you're not sure, let's check. Let's work it out. Let's clear what we're doing. 45 multiplied by 28, enter, divide by 100. Oops, 12.6. What have I done wrong? Oh, yep, it is 12.6, but then correct to the nearest integer. So we are actually correct. Equals 12.6, which when you round to the nearest whole number is 13. So which rounded to the nearest integer, so answer is correct. Integer, which is a whole number, equals 13. So yes, we have proven that it equals 13. So 12.6, which rounded to the nearest integer, whole number, equals 13. So we've just proven that the expected frequency, expected number of females more than 5 meals per day, we did row column by column total, divide by total. And we got 12.6, which rounds to 13. Use your GDC to find the chi-squared value. So x-squared calculator means the chi-square value for this data. This is one of the most important things you should try to remember. So we need to enter the matrix into the calculator first of all, and then it's a statistical test. So we're going to go stat test after that. So to enter the matrix, the 2 by 3 matrix into the calculator, we have to go, have a guess, second matrix. And do you see the word matrix kind of somewhere 4 buttons below the alpha, below the second button? So go second matrix, and then go across to edit. Make sure you try this out yourself. Second matrix, go edit. Turns out it is a 2 by 3, but if they had something else, if you wanted to change it to 3 by 2, you would do that. So let's just practice typing it in. 2, arrow across, 3. Ours is a 2 by 3. And now we're going to enter in all the numbers. So our numbers are 15, 25, 15 on the top. So go, make sure to enter them properly, or else things go all wrong and you get no marks. So 15, 25, 15. Then the next row is 12, 20, 13. 12, 20, 13. So I've just typed them in, but I need to look over and see have I entered in the right numbers. 15, 25, 15, 12, 20, 13. Good, we're good to go. Now that was second matrix to get to there. Now to find the x-squared value, the chi-squared value, it's a statistical test. So statistical, go to the stat button. See the stat button to the right of the alpha button? So go to stat, and it's a test. So arrow across to tests. And remember, x-squared test, the chi-squared test is way down below. So you've got to keep arrowing down till you get to the x-squared test. There it is, I just went past it. Oops, went way past it. Oh dear, went really way past it. Oh, now I've gone beyond it. Okay, x-squared test. So chi-squared test is the one, select it. Observed is in A, that's what we put in, matrix A. Expected frequency is going to be calculated for us in B, color blue, whatever. Just go down to calculate. You just go straight down to calculate. Here's our answers. So see, they've told us 3 answers. They've told us the chi-squared value, which is the value at the top. They've told us the p-value, which sometimes can be useful. Maybe they're going to ask for that later. So you might want to kind of like write it down somewhere. They've also confirmed the number of degrees of freedom, which we did in question B, is 2. So our chi-squared value, we should write it out to lots of decimal places. So I'm just going to scroll down so I can see the question. And now I'm going to write it out to loads of decimal places to begin with, and then I'm going to round to 3 sig figs. So if I make an error in rounding to 3 sig figs, hopefully they won't care because I wrote it out properly first. So the chi-squared value is x squared calc equals, let's get back to it, what was it again? 0.032066 dot dot dot. And then I'm going to round that to 3 sig figs. So hopefully I haven't made an error in rounding when I try to think. The 0.0, they're not significant because they're at the beginning of the number. But then we need, now our 3 significant figures begin. 3, 2, and 1. Because next to the 0 is a 6. So that rounds it up to 0.0321. And that's our chi-squared value done. Really important step because it's very popular in exams. E, considering that the critical value is 5.99, they have to tell you the critical value in exams these days, and that's what you compare to the chi-squared value, which you just calculated. Decide whether or not we reject or accept the null hypothesis. Justify your answer. So first step is say which one is bigger. Is your calculated value bigger than the critical value? No, it's less. So you might want to say x squared calc is lower than the critical value of 5.99. So your x squared calc is this one. That's lower than 5.99. If your calculator has lost, remember the way you remember it? If your calculator has lost, then there's no relationship between them. So your calculator lost because it was lower than the critical value. So that's in terms of the chi-squared value, which means that there's no relationship. So, which means no relationship means they're independent. Don't say no relationship, just say they're independent. Which means gender, and I don't have much space, so I'll just say meals per day instead of average meals per day, are independent. If your calculator value is lower than the critical, the two variables are independent. Which means we accept the null hypothesis, because the null hypothesis, remember at the top, says that they're independent. So we accept HO, which says that they're independent. So we've justified our answer, 2 marks there. And we've said the reason why they're independent is because the chi-squared value of 0.0321 is lower than the critical value. Now remember I told you keep an eye on the p-value because you might need it. State the p-value and describe how it confirms your answer for E. So let's grab our p-value. Our p-value was 0.98409. 98409, maybe write out a few more decimal places. 0945006, something like that. 45006 dot dot dot. Then round it to 3 sig figs. So the 0 at the beginning is not significant. Now our significant figures begin. 984, because next to the 4 is a 0. So our p-value is 0.984. So we compare the p-value to the significance value. And remember the significance value is at the top of the question. 5% level of significance. So significance level was 5%. And remember you've got to write it as a decimal, which is, so as a decimal, let's just divide by 100, 0.05 as a decimal. I should write as a decimal. As a decimal. And so our p-value, would you agree, is greater than the significance level? So the p-value that we calculated is greater, not lower this time, than the significance level as a decimal. So for the outcome of the p-value, if your p-value is greater, then that still means they're independent. If your p-value is lower, then it means they're dependent. So it's the opposite of the chi-squared. If your calculator on the chi-squared said that it's higher, so sorry, in this case it said it's lower, that means they're independent. And vice versa. If the p-value says it's greater, that means then the significance level is a decimal, that means they're independent. Therefore, we can say gender, and so of course it's going to back up what the chi-squared says. Gender and meals per day are independent. And like we said before, we can also add we accept HO, so we accept the null hypothesis, and we reject the alternate hypothesis, H1. So that's one set of chi-squared questions all done, and that covers a lot of chi-squared, but we probably want to just try one more. One more is an example of where they don't give you the matrix, but maybe they're just going to give you some values. So here's one where they don't give you the matrix, but you can still calculate, or you can still make a conclusion based on what numbers they give you. So a market researcher consulted males and females, so gender, to determine whether the type of coffee they drink is associated with gender. So our two variables would be gender and type of coffee. So gender, of course, there's just male and female. And type of coffee, how many types? There's cappuccino, latte, americano, macchiato, and espresso. So there were 5 different types of coffee. So our, try to imagine the matrix would be a 2, so it would be a 2 by, actually, a 2 by 5 matrix, because you'd have 2 rows and 5 columns, gender and 5 different types of coffee. So it would be a 2 by 5 matrix. Write down the null, instead a chi-squared test, notice they said x-squared test again. So a chi-squared test was conducted at a 10% significance level, important bit of info. And the chi-squared value, you're not going to have to calculate it because they told it to you, is 8.73. So that's our x-squared calc value. So you're not even going to have to calculate it. So it doesn't matter you don't have the matrix. Write down the null hypothesis. So just reminding you that null hypothesis is HO, just because that might be helpful. What you do need to write is what I'm about to write. So gender and, remember you just write the 2 variables, gender and, what was it, type of coffee, type of coffee drunk, are independent. If it was the alternate hypothesis they want, you would have to write gender and type of coffee drunk are dependent. So that's what they're asking for now, the alternate hypothesis. Alternative hypothesis, quite often called the alternate hypothesis. Just write the same thing, go gender and type of coffee drunk, and then what do you write instead of are independent for the alternate hypothesis? You write are dependent. So see, they're the same sentence. You don't say they're associated with each other or one relies on the other. You just write the 2 variables with an and in between them and put are independent for the null and are dependent for the alternate. Now write down the number of degrees of freedom for the test. That's why I made you imagine what the matrix would look like. So remember, degrees of freedom equals rows minus 1 times columns minus 1. And we've got gender, so it's a 2 by, and types of coffee, there were 5 types of coffee according to the question. So it would have been a 2 by 5 matrix. So we can write equals 2 minus 1, 5 minus 1. If you're not sure, as I said, throw it in the calculator. So second quit. Oops, again. So there's second quit. Brackets. You can put in 2 minus 1, just showing you that if you're not sure how to work that out, you've got your calculator. Don't worry about it. 5 minus 1. Lovely. If you've got it right, the answer is 4. 4 degrees of freedom. Because 2 minus 1 is 1, 5 minus 1 is 4, 1 times 4 is 4. So we've found the number of degrees of freedom. So they've said considering the critical value is 7.78. Remember, our calculator value is 8.73. So considering the critical value is 7.78, state whether the type of coffee drunk is independent of gender. I tend to first of all say, was my calculator value higher or lower than the critical value? Because that's the mark you get for reasoning. So our calculated value was 8.73. The critical value was 7.78. So our calculated value of 8.73 was higher than the critical value. It was higher than the critical value of 7.78, because that's going to get you your reasoning mark. And now you've got to say, what's the conclusion? Therefore, gender and type of coffee are, you've got to say, are they independent or dependent? So remember, has your calculator won? It's a chi-square test, not the p-value. So calculator 1, did it win? Yes, your calculator won because your calculated value was higher than the critical value. So therefore, remember, when your calculator wins, you've proven that they are dependent. When your calculator loses, you've proven that they're independent. The way one student remembers it is they try to think, in your internal assessment, you're trying to prove that they're dependent, so you want your calculator to win. So that's one way you might be able to remember it for the exam. If you've got another way, you go for it and you use that. And that's the end of the chi-squared test lesson. Thank you for watching.